Hi everyone, and welcome back to this series of practice problems about different topics in numerical methods. And today we'll solve 3 questions about interpolation. And again, for the describing the concepts of interpolation, I will leave a link in the description of the video that gives you some lectures about what is interpolation and how we come up with the formulas that is described in this data or in this series of problems. So let's start with the first question here. It says find the highest order polynomial. So it didn't specify the order of the polynomial, but it said the highest. Okay, and you are giving here the series of the data points using both the direct method and the Newton's divided difference method. So we'll use these 2 methods to find basically the polynomial, and we need to calculate the polynomial at f3.5, which is a point somewhere here that we don't know its value. So we'll start with the direct method. In the direct method, basically, y is equal to a0 plus a1x plus. But before we write the whole equation, we need to decide what is the order of the polynomial. So we have here 1, 2, 3, 4, 5. So n is equal to 5. The degree of the polynomial is n minus 1, which is equal to 4. So it becomes a0, a1x plus a2x squared plus a3x cubed plus a4x to the power 4. So that is the general formula of the polynomial. And now we need to find a0, a1, a2, a3, and a4. So we have basically four unknowns. And how to do that? The first thing we need to do basically is to generate 5 equations. How to generate 5 equations? We'll use these basically 5 points that we have here in the data set, because those points basically satisfy this polynomial. So we'll start, for example, for the first equation. So I will just substitute y here is equal to 3 is equal to a0 plus a1 times x is 1, plus a2x squared, so plus a2x squared is 1, plus a3 plus a4. So that is my first equation. My second equation is basically 5 is equal to a0 plus a1x. X is 2 now, so this is equal to 2a1 plus a2x squared, so 4a2 plus to the power of 3, it's 8a3, and finally plus 16a4, and this is your second equation. And now you can generate the other 3 equations. Now when you are done with this, you get this system of equations. So this is our first equation, this is our second equation, and we need to solve for this vector a0 to a4. Now here we can use for example the technique that we mentioned before, which is the Gaussian elimination, to solve for that. And once we solve, we get this. Basically these are the coefficients. So your function, your y, is equal to 9.75 minus 14.125x plus 9.125x squared minus 1.875x cubed plus 0.125x to the power 4. And now I need to find, this is your f of x. I need to find f at 3.5. So I need to substitute all the x value with 3.5. And if you do that, you will find this is equal to 10.446. Now, as you can see here, this method is straightforward. It's called direct method. However, solving this system of equation without the use of a computer is not an easy task to be done. So this is why the Newton's divided difference method is a better way of doing this. So here, let's do this. So here we have n, which is we have 0, 1, 2, 3, and 4. We have our x, okay, and we have our y. So your x basically is equal to 1, 2, 3, 5, and 7. Your y is 3, 5, 9, 11, and 15. Okay, so this is where we start here. This is just the number of points, and it doesn't really contribute to the how to find the equation. So basically now we'll go 3 and 5, 5 and 9, 9, 11, 11 and basically and 15. So we will have 5 minus 3 divided by 2 minus 1, and this will give you 2. 9 minus 5, 9 minus 5 divided by 3 minus 2, and this will give you 4. 11 minus 9 divided by 5 minus 3, so it's 2 over 2 will give you 1. And finally, 15 minus 11 over 7 minus 5 will give you 2. Now, basically, this is your B0. This is your B1, and we move on. Okay, so it now becomes 4 minus 2 divided by 2, or sorry, 3 minus 1, which is equal to, basically, this is equal to 1. And then here, 1 minus 4, 1 minus 4, 1 minus 4 divided by 1 minus 4 divided by here. This is 5 minus 2. 5 minus 2, which give you minus 1. And then finally, 2 minus 1, 2 minus 1 divided by 7 minus 3. Okay, and this will give you 0.225. Now this is your B2. Keep on. So it becomes minus 1, minus 1. Okay, minus 1, minus 1. So this is basically, we would go from 5 minus 1, which is equal to minus 2 divided by 4, or minus 0.5. And here would be 0.25 minus minus 1 divided by 7 minus 2, 7, which is 0.25 minus 1 here, so it becomes 7 here, and this is minus, basically minus, sorry, minus 3. This is will become equal to 1.25 divided by 4. I think there's something wrong here. Okay, so let me just trace it back here. So this is between okay, divide by 2, sorry, divide by 2. So here this is 7 and 2. So therefore not be confused. So this is the starting and this is the end. This is 5, and this will give me 0.225. Finally, we will have these two together, which is basically 0.25 minus 0.5 divided by 7 minus 1, and this will give me 0.75 divided by 6, which will give me 0.125. Now, what is my function? F of x equal to B0 plus P1 x minus x0 plus B2. Now this is B2, this is basically B3, and this is your B4. So it will be 2x minus x0 times x minus x1 plus b3x minus x0, x minus x1 times x minus x2, and finally plus b4 x minus x0, x minus x1, x minus x2, and x minus x3. So we have all the b's here. b0, this is your b0, b1, b2, b3, and b4. Now x, this is your x0, x1, x2, x3, and this we don't need x4. Okay, so that is the function. Now, if you open this, you will get exactly the same as this function. And if you substitute your f of 3, as we found it here, 3.5, you will find this is exactly equal to 10.446. Okay, now let's move to the second question. Now here in the second question here, interpolate the following data to estimate the pressure at 3 minutes. So we have here, this is the time and this is the pressure, and at 3 minutes it's missing the data here using highest order of polynomial. Again, we have to figure out this. We have 1, 2, 3, 4, 5, 6. So your n is equal to 6. So the degree of the polynomial will be equal to 5. So basically your function y is equal to a0 plus a1x plus a2x squared plus a3x cubed plus a4x to the power 4, and finally plus a5x to the power of 5. Now substitute. If you, for example, start with the first point here, so 7.5 is equal to a0 plus everything else 0, because all the x's will be 0. So it's equal to 7.5 is equal to a0. And then you can go and substitute the second one and so on and so forth. So you will get this 5 by 5 system of equations. Okay, now solving this again, we'll use the Gaussian elimination. If you do that, you will find this is the solution of a0 to a5. So from this, you can say that your f of x is equal to 7.5 plus 1.79x minus 0.201x squared plus 0.0023x cubed minus 0.0013x4 plus 2.54 times 10 to minus 5x power 5. Now you noticed here in this formula that as you increase the order of the polynomial, the coefficient getting less and less. And you see that because the function can be approximated by a linear function, maximum by a second order. So all these terms doesn't really contribute much to the accuracy of the results. And now I want to find basically the pressure at 3 times equal to 3, and this is will be equal to 10.95. Now let's go to the Newton's method here. Okay, so we will have 0, 1, 2, 3, 4, and 5. So this is your n. Then we will have our x. So your x is 0, 2.5, 5, 10, 15, and 20. So, and then this is your y. Your y is 7.5. This is basically your data from the table: 10.5, 12.5, 15.8, 17.9, and 19.4. Okay, so we start, this is your B0. Now we will do the divided difference method. So 10.5 minus 7.5 divided by 2.5 minus 0, and this will give you 1.2. 12.5 minus 10.5 divided by 5 minus 2.5, and this will give you 0.8. And now we can repeat the same thing. I don't need to repeat that. So this is 0.66, 0.42, and 0.3. This is your B0. This is now your B1. So now we will continue here. So for example, in this one will be 0.8 minus 1.2 divided by 5 minus 0, and this will give you minus 0.08, and then minus 0.01867, minus 0.024, and finally minus 0.012. Continue. So we will have this minus this, okay, and divided by the interval. Now it's not from 5 to 0, it will become from 10 to 0. And now let's just have the values: 0.00613, minus 0.00043, and 0.00008. Now this is your B2, this is your B3, two more, so this will give you minus 0.00044, and this will give you 7.0110 to minus 5. Finally, this will give you 2.54 times 10 to minus 5. This is your B4, and this is your B5. So we found all the parameters now. You follow the same procedure, so it's very systematic. And then from this, you will find that your f of x is equal to B0 plus B1 x minus x0 plus B2 x minus x0 times x minus x1 plus B3 x minus x0, x minus x1, and x minus x2 plus B4 x minus x0, x minus x1, x minus x2, and x minus x3. Finally, B5 x minus x0, x minus x1, x minus x2, then x minus x3, and finally x minus x4. Now, this is x0, x1, x2, x3, x4. So we have all these x's, we have all the b values. So now when you substitute as expected to find f at 3.5, you will get 10.95 as we found before. The last question here says use cubic polynomial. So here we are giving the order, and we are using the highest order here, okay, because this is n equal to 4, so cubic is the highest. To predict x at equal to 1.25 now becomes very straightforward. Your n 0, 1, 2, and 3, your x is basically 1, 1.1, 1.2, 1.3, and your y value is 0.14, 0.21, 0.3, 3.54. So now we move here. So 0.21 minus 0.14 divided by 1.1 minus 1, and this will give me 0.7, then 0.33 minus 0.21 divided by 1.2 minus 1.1, and this will give me 1.2, and finally 0.54 minus 0.33 divided by 1.3 minus 1.2, and this will give me 2.1. Now this is your B0, this is your B1, so we need two more stages here. So this is 1.2 minus 0.7 divided by 1.2 minus 1, and this will give me 2.5, and then this is 2.1 minus 1.2 divided by 1.3 minus 1.1, 1.3 minus 1.1, and this will give me 4.5. Finally, this is your B2 now. So finally, 4.5 minus 2.5 divided by the whole range, which is 1.3 minus 1, 1.3 minus 1, and this will give me 6.67, and this is your B3. So your function f of x equal to B0 plus P1 x minus x0 plus B2 x minus x0 times x minus x1 plus B3 x minus x0, x minus x1, and x minus x2. So we have all B0, B1, B2, and B3. We are all given these values. Okay, and we have all the x's, x0, x1, and x2. Let me write it down. This is not a big formula. So we have here 0.14 plus P1 is 0.7, x minus x0, which is 1, plus P2, which is 2.5, times x minus x0, which is 1, times x minus x1, which is 1.1, plus P3, which is 6.67 times x minus 1, x minus 1.1, and finally x minus x2, which is x minus 1.2. Now substitute f at 1.25. You will get this is equal. Now you substitute all the x values. You will find this equal to 0.4213. 0.4213. And that is the end of this tutorial.